For our next example, we're going to actually look at a rational function. So it's going to be a little bit more complicated, even though the equation looks easier. The math we're going to have to do is going to be a little bit more complicated. So we're going to start it off by plugging in our formula again. So in this case, and we're doing it at x equals 3. So to find the slope, it's the limit as h approaches 0 of f at 3 plus h minus f at 3 all over h. So I'm going to plug in 3 plus h into this function. So instead of 1 over x, it's 1 over 3 plus h. And I'm going to plug in 3. So it's just 1/3. So the catch is when you have to subtract these things, and they're fractions, because it's a rational function. So we got to remind ourselves how to subtract fractions. We need what? That's right. We're going to need common denominators. So I'm going to do something off to the side. I'm going to put it on here so the people on the video can watch, so you don't have to write this down. If I want to find a common denominator and the denominators are 3 and 4, what's the easiest way to find a common denominator? Multiply them, right? So in this case, it's 12. Okay, is the common denominator. It actually works for other stuff. Like if I had 1/6 plus a half, I know that 6 is a common denominator, right? That'd be easier. But you can also use 12. There's no rule that says you have to use 6. 12 is also a common denominator. You just get them by multiplying them together. It always works. It's easier to find the lowest common denominator because then your math is a little bit easier, but you know a common denominator will always work if we have that. So what if I had like 1 over x plus 1 over y? What would a common denominator of those be? xy, right? So xy and xy. So in our case, our common denominators, well, I've got a 1 over 3 plus h and I'm subtracting a 3. So our common denominator is going to be something we multiply. So it's going to look like this. See how those are the two that are multiplied together? 3 times 3 plus h. I write the 3 first just because it's out front, but it doesn't really matter. Okay? So that's our little common denominator part. All right, so I'm going to erase all that, so I'm going to actually do it. So the easiest common denominator is found when multiplying the denominators together. And so I'm going to do that. Oops. This is where it's even more important to remember the divide by h part, because you're going to be doing these fractions on the top that you think you might have already done the division bar, and we haven't. All right, so if the common denominator is 3 times 3 plus h, we got to figure out what the top needs to be in each of these. So I'm going to ask, what did I multiply by this to get this? 3. So this got multiplied by 3 to get that. So I have to do that same multiplying on the top. So good news is it's 1 times 3, so that's just 3. I'll ask the same thing for this denominator. What did I multiply by 3 to get this denominator? 3 plus h. Right, times 3 plus h. So I got to do that on the top. And it's 1 times 3 plus h, so it's just 3 plus h. Once I have a common denominator, I can keep the denominator and add the numerators. For some reason, I have a little division bar here. I got a little carried away. So ignore that. So on the top, I'm going to keep the denominator, 3 times 3 plus h. And I'm going to add or subtract the numerators. So in this case, it's 3 minus, and I'm minusing this whole thing. So I got to minus this part, and I got to minus this part. So that's going to become a minus 3 and a minus h. All over h. On the top of that fraction that I just brought together, it's 3 minus 3, which is good news. That's going to be a 0, and that's going to leave me with a minus h over 3 times 3 plus h all over h. Now you notice I haven't actually multiplied the 3 times 3 plus h. That's on purpose. You're going to see why in a moment. I've just left it like this. All right, now on the one before, we could do all sorts of canceling. Well, it's not quite as simple in this case. You can't just cancel all these h's. But what I can notice is I have a fraction being divided by something else. So on the top is this fraction here, and it's being divided by this thing. Well, how do you divide by fractions? How do you divide fractions? Multiply by the reciprocal. So I'm going to do that in this next line. So it's limit as h approaches 0 of negative 1 over, or h over 3 times 3 plus h times the reciprocal of the bottom. Well, this is h over 1, so the reciprocal is 1 over h. That's a big step when you multiply by that reciprocal. Because now, if you notice, I have an h on the top of a fraction and an h on the bottom of a fraction. H divided by h is going to be 1, so this h and this h can cancel. And I'm set. I can do the multiplying. Since the h is canceled to a 1 and a 1, when I multiply the top, I have a negative 1 times 1, so that's negative 1 on the top. And on the bottom, it's this 3 plus 3, or 3 times 3 plus h times 1, so it's just 3 times 3 plus h. So, why is that so significant that the h disappeared? Well, I can actually start to take the limit now. Even though there's an h on the bottom, it's not going to result in a divide by 0. You see, if I put in h equals 0 right here, it's not going to result in a divide by 0. So I can actually start to take the limit at this stage. So that's good news. I don't need to have write the limit part anymore. I can actually take the limit. It's negative 1 over 3 times 3 plus 0 now. That 0 is not going to result in divide by 0, so things are good. It's negative 1 over 3 times 3, which is negative 1 over 9. And so it turns out the slope of the tangent for this one is negative 1 over 9. Key on that is being able to remember that you're going to take a common denominator, bring it together correctly, and when you divide by h, you multiply by reciprocal. That's where your canceling happens.